Now that we've talked about coterminal angles, we're going to talk about reference angles. So what's a reference angle? Okay, well, maybe let me illustrate it on a picture first, and we're going to write a sentence that describes it. Okay, so imagine I've got this angle here. I guess I don't really need my new circle right now. So this is my angle. The reference angle is going to be the angle between the terminal side and the x-axis that is acute. Okay, so what do I mean by this? Now my terminal side is right here. Okay, and the x-axis is over here. Okay, now there are two angles between the terminal side and the x-axis. There's this one and there's this one. The reference angle is the one that's acute. So in this picture it would be this. Okay, so this is my reference angle. So and it's going to be acute and positive. So it's going to be like that. Okay, so my reference angle is, since it's acute, it's an angle between 0 and pi over 2, so between 0 and 90 degrees. So it's an angle in the first quadrant, really. So the angle we're looking for would be illustrated as follows. It would be here. Okay, so that these are the same. So maybe to put numbers, okay, next to my angles. Imagine this is a rotation of 200 degrees. Okay, it makes sense. It's a bit more than 180. 180 is half a rotation, so it's half a rotation plus something, right? So my the acute angle turns out to be, well, it's 200 minus 180, right? So it would be 20 degrees. Okay, so that would be the value of this acute angle. So that would be 20 degrees here. Okay, so let's write down what the reference angle is. It's the acute angle. So it's going to be in the interval 0 pi over 2 or 90 degrees, right? So it's the angle between the terminal side and the x-axis. It is an angle because it's acute and positive in the first quadrant. It is in the first quadrant. Okay. So maybe I show you another example here. Let's say I have an angle of let's say in the I don't know, maybe here. Okay, maybe I'll use red color as before. Okay, so maybe I have an angle of minus 60 degrees. So I'll write it here, minus 60 degrees. Okay. Now, if I look at the acute angle, okay, between the x-axis and the terminal side, it's actually this. Okay, it's an angle of 60 degrees. So it actually is. So it will be this angle here, 60 degrees. Okay, you would get this green ray here by just mirroring the red ray across the x-axis. So you see that depending where your angle lies, okay, whether it's in the first, second, third, or fourth quadrant, the way to obtain your reference angle is kind of different. So it's always better just to draw a picture, and from this you can recover pretty easily your reference angle. So the big question that comes to mind is, why do we care? Like, why are these important? Okay. And again, I'll show you that. So why are reference angle important? Reference angles important. Okay. Well, let's take a look at another example more closely. And this time I will draw a circle, okay? And imagine I've got this this rotation of it's a rotation. Maybe I'll use the red color again. So let me just erase that. So it's a rotation of 11 pi over 6. So what's 11 pi over 6? Remember, 12 pi over 6, that's 2 pi, right? So 2 pi is a full rotation. So it's almost a full rotation, but we're off by pi over 6, okay? So this is 11, 11 pi over 6, okay? And what's our reference angle here? Well, it's the acute angle that's right here. This is our reference angle. And so what's missing to complete the rotation is pi over 6. So that's its value is pi over 6. Okay. So if I mirror the red ray, I will obtain this ray, and I will obtain my angle pi over 6. Okay. So reference angle is pi over 6. Now, so why do we care? Let's say I want to find, and eventually this is something I'll want to do. I'll want to find the coordinates of this point which intersects the terminal side with the unit circle. Okay, or any circle actually. Okay, it doesn't have to be unit actually, but eventually we're going to be working a lot with the unit circle. So let's say I want to find the coordinates of this point here. Okay. Now, if I take my reference angle, it also has a ray which, well, its terminal side is going to intersect the circle. So suppose I actually know the coordinates of this point. Okay, it turns out, and this is, I'm not making this up, this is actually root 3 over 2 and 1/2. And we're going to see in the next section why those are the coordinates of this point when the angle is pi over 6. Okay, so think about those as A and B. Okay, so suppose I know those coordinates. It's pretty easy to find the coordinates of this other point. Okay, the point that is where my the terminal side of my original angle intersects the circle. So in this case, it has the same x coordinate, but an opposite y coordinate, because it's you mirror this coordinate, well, this point across the x-axis to get the other point. So this will turn out to be A and minus B. So the whole point is that our reference angles, okay, the point here will have coordinates that will be plus or minus the coordinates of the point that's intersecting the terminal side of our given angle with the unit circle. So if we know the coordinates of this point for well-known reference angles, it's going to be easy to find the coordinates of points for other angles that are not in the first quadrant. So this is why we care so much. So that we're going to be using this principle a lot in the next section. So I will just write that up. Okay, so the coordinates on the unit circle of a point on the terminal side of the reference angle are equal or the opposite of the coordinates of the point on the unit circle and the terminal side of the given angle. And maybe to conclude, I'll give you another example of that. So imagine this is the unit circle, and I've got an angle that's of maybe, I don't know, 3 pi over 4. So 3 pi over 4 is this. Okay, so 3 pi over 4. So it's pi over 2 plus pi over 4, essentially. The reference angle is the acute angle here. This is the reference angle. And you can find its terminal side by mirroring the terminal side of the given angle across the y-axis this time. Okay, and therefore we end up with an angle of pi over 4. If I know the coordinates of this point, okay, then the coordinates of this point are very easy to obtain. They're just going to be the opposite of A, because we're just reflecting this point across the y-axis. So it's going to be minus A and B. It turns out that I actually know the coordinates at pi over 4, and so will you in the next section. It's root of 2 over 2, root of 2 over 2, and therefore very easily I'm going to be able to find the coordinates of this other point, which is at the intersection of the unit circle and the terminal side of my given angle. So this is why we care. Eventually we're only going to need to know the coordinates of points in the first quadrants for some very specific angles, and from this we're going to be able to recover the coordinates of other points for other specific angles, but in other quadrants. So instead of remembering coordinates of 20 points, okay, we're going to only have to remember coordinates of a few selected points in the first quadrant, okay, and the rest will follow by geometry, and this geometry is linked to how we obtain our reference angles. So I hope this helps. In the book they talk about reference angles, but they don't mention why we care about them, and it becomes very explicit in the next section.